Time seems like a thing where there is no thing. Time seems like a thing, but science can't find that thing. When you go right down to it, science can't find time itself. This is a video exploring time, what time is, what time is not. Most specifically, time isn't time. It's not a noun, it's not a thing out there that we can find. One way to see this or to talk about it is say it's simply timing. It's the timing between things being in motion. And everything is in motion. On the smallest quantum molecular level, on the biggest solar system, galaxy level, everything is motion. It's quite universal. I was surprised when I found out that science doesn't know what time is. So I decided to do a little experiment, thinking about it, trying to figure out for myself, well, what do I think time is? So breakthrough for me came when I was thinking about the 3 dimensions and the 4th dimension. 4th dimension is supposed to be time. So do a little demonstration of what I was thinking in my head here. And 1st dimension is a line, one straight line. 2nd dimension is a square, flat surface. 3rd dimension is depth. Nice and easy, straightforward, no problem. I get it, makes a lot of sense. Where is the 4th dimension? And everywhere I looked, every which way I tried to see what was going on, all I could find was the 3rd dimension, the 3 dimensions. Everything was within those 3 dimensions. I couldn't find a 4th dimension. So I had this little intuition, which was reach in and twirl the cube. What I hadn't realized before was the cube in my imagination was completely static. It was steady. It was just sitting right there. That was it. And there was no motion. So twirling the cube brought in motion, and it seems so simple. Like, yeah, well, yeah. But bringing in motion changes it makes everything dynamic. It changes everything within the 3 dimensions. Is constantly changing when it's in motion. So that was interesting. And after looking at it for a while, what I came to was that we can say time is timing between things in motion, or if you want to, we can just go straight to it and say time isn't time, it's motion. So what about clocks? Science steps around the difficulty of saying what time is by just saying, we're just going to say time is what a clock reads. It's what its clock says. That's it. We're not going to explore it further than that because we can't quite come up with anything. So let's look at clocks. So my question is, if you have a fast clock, is it measuring time? If you have a slow clock, is it measuring time? So how if a fast clock was going twice as fast as it's supposed to, is it still measuring time? Or twice as slow as it's supposed to, is it still measuring time? At what point do we say, that's not really measuring time? The other question is, faster and slower than what? Faster and slower than something in between here that is time itself, that runs on time because it is on time, it is time something, but we can't find it. Or faster and slower than each other, that seems like one way to look at it. Or faster and slower than the rotation of the Earth. Because clocks are made to replicate steady, constant motion of the Earth. So, rotation of the Earth is a motion. The spinning of a clock is a motion. And so if I say time isn't time, it's motion, what comes back is you can't say that because science uses time to measure motion. A car going 60 miles an hour is from point A to point B in 1 hour. That 1 hour is time. Come on. So what I'm saying is the car going from point A to point B is doing it the same time, the same timing as 1/24th of the spin of the Earth. You can also call that 1 hour on a clock, but it's based on 1/24th of the spin of the Earth. That is simply timing. There's not inherently some kind of thing out here called time. Also, the speedometer of the car is a needle that goes up and down. There's no clock in that system. Speedometer works through friction or electromagnetic. It's just faster and slower. It's just registering faster and slower. There's no actual measurement of time in a speedometer. So it doesn't need it. So what we boil it down to is we're using motion to measure motion. It doesn't seem like it at first, but when we're using time to measure motion, we're just using steady, reliable, consistent motions to measure other motions. One of the other things that people talk about is the arrow of time. Time goes one way, it doesn't go back the other way. That's time for you. So, you see time as time, then this makes a certain amount of sense. If you see it as motion, it doesn't make quite as much sense because there's a lot of things that you can reverse and make go backwards. Put a molecule of water in a little box and you freeze it. Say time is going this way, it turns from water to ice. But if you put heat back in the box and thaw it, now you got ice going to water. Time go backwards in the box? Doesn't seem like it. I mean, I wouldn't call that time. So there's a lot of processes that you can reverse. You can't unburn a match. You can't get the totality of every single motion in the universe to reverse. Absolutely. So if you subtract all the ones you can reverse from all the ones that are going forward, would that slow down time or something? No. So you see time as motion, the arrow of time stops making quite as much sense. The thing is, we have this sense of time. It's very strong. It's hard to get around that, actually. Why do we have this sense of time? Well, a couple of reasons. One of them is that when we use our brain, we're nearly always engaging memory, and memory is of the past. And you can use it to extrapolate the future, but as long as you're seeing anything and engaging memory, comparing it to memory, involving memory, you're going to see it in this past-future reference. And that inherently gives you a sense of time. Also, we've evolved on this planet with these constant, steady motions, the Earth and the Moon and the Sun. And so that's what we've used for timing all this time. So it's in our psyche, it's in our DNA, it's in our language. The most commonly used noun in the English language is time. It's embedded in there. We're not just going to be able to snap our fingers and undo that or stop using that word. Also, all these motions that science has found, the quantum motions and the galactic motions and these things, they were utterly invisible to us before. So a whole lot of this motion we couldn't see. We could see effects from it, but we couldn't see the cause. So there's this sense of everything changing and happening, and we have to attribute it to something, hence the concept of time, hence our idea of time. I'm doing a video of this bit on a different day. Things have changed. Stubble's grown in, all kinds of things have changed. Different day, things change from moment to moment, things change from year to year. That's time, yeah? Things age. Surely that's time. So let's look at something that's aged. Say an old wooden fence post. Been in the ground 40, 50 years or something. It's weathered. It looks old. That's the effects of time. Yeah? Okay, so let's make a list of everything that's had an effect on that old wooden fence post there and keep them in order of what happened first, second, third, and so on. Oxidation, UV from sunlight, microorganisms, freezing, thawing, blah, 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 etc., etc., etc. It's a really long list of things that have happened if we look scientifically at every cause and effect. I think what you'll find is that time is not on that list. It has no direct cause and effect on the fence post. So the closest thing that we can find to time is the list itself. What comes first, what comes second, third. And that is back to timing. This is the timing of everything happening within everything else happening. It's just the timing, not actually time itself. So I think what we find is that all the changes are due to everything interacting. And everything interacting is due to everything being in motion. So what I want to say here is science, you're the one who found all this motion. It was invisible to us before, so much of this motion. So use the scientific method. Get to the causes of all these effects that we currently attribute to time. I think you'll find that motion is at the bottom of this. There's a lot of things that wouldn't change that much, whether we see it as time or timing or the underlying cause of motion. Most things, we're going to go about our day pretty much the same. But there is one thing that would definitely change, and relativity says that space and time are one cohesive thing, with 3 dimensions in the 4th dimension, all one cohesive unit. So if time isn't time, if it's actually motion, then we end up with space motion, maybe? What's that? Well, what I realized is that most of the motion that we experience is mass moving through space. So space motion is kind of incomplete. It needs mass in there to make sense. So end up with a theory that said motion, space, and mass together as a complete unit are a thing. That's a theory. A surprising number of things drop into place with this theory. The quantum context, the smallest, fits with our larger Newtonian. It brings in relativity, a kind of more expanded view of relativity. It ties in with black holes and cosmic voids, the giant space bubbles that we're now discovering. It also relates to the expansion of space, so it touches on quite a few things. I wonder what that's about. Medium.com, under quantum context. Oh yeah, that's it. I have my theory all written out. You can go check it out there, because I'm not going to explain it all here. It's quite simple in a way, but it's also has a lot of permutations. So if you're into scientific theories about stuff, go to medium.com, quantum context. Check it out.